Assalamu alaikum and good morning. I'm Fuad Hassan Aden. I'm going to present my project that is entitled as Switchable Antenna System Based High-Speed Wireless Railway Communication. So let us start it. So this is my outline that I would like to present it today. So first of all, this is the UK corporate letter, which is a registration certificate that certified that the work switchable antenna system based high-speed wireless railway communication was registered with the UK Corporate Service on 9 July 2020. This is the collaboration letter which receives on K&H Dynamic Resource. This company is located on Johor, especially Taman University, Sudan. The introduction of this project is in the development of the wireless communication system, they are looking forward to produce antenna with multi-functionality that can adapt with the changing scenario and operating requirements. In this term, reconfigurable antenna fulfill the requirements. This project proposes switchable beam parasitic patch antenna with a high gain performance that's suitable for point-to-point communication system. So types of the reconfigurable antenna, there is a 4 main types of the reconfigurable antenna, but this project we would like to focus on radiation pattern type. The problem statement of this project is the many antenna which based on reconfigurable antenna, it has been needed to require less complexity, high gain, and could be mastering capabilities. So mixed patch antenna have low gain and narrow bandwidth. It affects the performance of the mixed patch antenna in wireless connection. Number of wireless bridges along the path is increasing. The objective of this project, we would like to achieve 4 main objectives after the project is done, which is the first one to achieve a reconfigurable beam steering antenna with higher gain and more angle direction. To design a switchable beam antenna using switches at 5.8 GHz. And to provide better the connection stability and decrease the handover trigger. To produce the number of wireless bridges along the path. The methodology part. First of all, the stage 1, the driving element. As you can see here, this is a single circular patch antenna with the radius of 9.42 mm based on this formula. And the antenna operates at 5.8 GHz. This bit rate is a Taconic TLY5. The main reason that we choose Taconic because it has low dielectric constancy and their thickness can give the best efficiency and large bandwidth. Stage 2, after we reach optimum result, we design our driving parasitic antenna, which consists of 4 parasitic elements surrounded by a driving element. There is a 4 RF switch. This RF switch is called HBND4005 PIN Diode. This PIN Diode support up to 18 GHz data sheet provided by the manufacturer. The HBND4005 PIN diode are simulated as 4.7 ohm resistor and 0.017 capacitor in the on and off state respectively. There is, as you can see here, there is a 4 inductors which is a DC biasing circuit. These inductors perform on the RF coax to allow the current to flow to the PIN diode through the parasitic element and avoid the outflow current from the parasitic element into the DC lines. The distance between the driving and parasitic allows the mutual coupling between elements, and the mutual coupling effect is used to steer the beam in a desired direction by the short beam. On state acts as a reflectors and off state acts as directors that will tilt the radiation pattern, and the gap between the driving and parasitic element is kept by 2.70 mm. As you can see here, the application of this project is a railway communication, and we would like to put our antenna the top of the train, which is in this switchable antenna system. It has 5 different modes and can steer 5 different directions. The advantage of this project because it is a simple and reliable design structure, stable S11 at 5.8 GHz, capability to achieve its steering angle from -45 to +45 degrees, better connection stability and decrease handover trigger, improvement in signal reception, number of wireless bridges along the path can be reduced, reduction in handover triggering time. The result and discussion in this part. First of all, the driving structure result. You can see here the S11 for the driving element. The operating frequency obtained is 5.8 GHz with return loss of minus 31.91 dB. This shows that the operating frequency has a return loss that is less than minus 10 dB, which shows the antenna was operating satisfactorily. And this is the gain of the antenna, which is 8 dB, and 2D efficiency, which is the total efficiency of this antenna is more than 90%. And this is the driving parasitic result. As you can see here, this is the simulated S01 in 5 different modes, and this is the polar radiation pattern, which the maximum steering angle that we reach is a 45 degree. This is for the simulation for the 3D radiation pattern of the antenna. You can see when it was minus 45 degree, it is still like this kind, which is on, off. And this is for plus 45, which is off, on. And this is the 3D radiation pattern shows the antenna is still in 5 different modes. And this table shows the configuration for the HBND4005 PIN diode switches, which shows the operating frequency in different modes, reflection coefficient, gain, antenna efficiency, and beam steering. So for the maximum gain that we reach is 8.92, which in this condition was on, off, on. And the maximum tilt angle that we reach is during 45 degree. And the total efficiency of this antenna, the 5 different modes, all of them is above 90%. So I would like to conclude this project. The main aim of this research was to investigate and design switchable PIN antenna with the introduction of the parasitic element using PIN diode switches at 5.8 GHz, and also to achieve high gain performance antenna that is suitable point-to-point communication system, especially railway communication. Therefore, the objective of this project has been successfully achieved based on Yagi-Uda parasitic array antenna. The simulated result shows better performance of the proposed technique, where the reflection coefficient for each beam steering is below minus 10 dB and tilt angle is increased up to 45 degrees. Here I would like to share with you the publication's progress, which is 2 main conference paper. Which one is entitled Design of Enhanced Textile UWB Antenna with Rectangular Slot for Wearable Application, which is under progress in conference paper in Scopus, and the other one is entitled in Switchable PIN Antenna with a 5-planar element using PIN diode in elevation plan, which is submitted on to the PCWSP 2020 conference. And this is my reference. That's all of my project. Thank you.